The Arc B580 has launched, and with it bringing Intel's Battlemage technology to the masses. In this video, we're going to go over the benchmark results of this limited edition GPU and talk about how Intel slots into the GPU market. You see what I did there?
Let's go, gamers.
That was your joke. I just stole it. Welcome, PCWorld fans, to this review of the Intel Arc A580. This was a team effort here at PCWorld to get these GPUs benchmarked. I'm Adam Patrick Murray, and I did the actual testing of this GPU, but I didn't do it alone. I had help from one Will Smith, who helped me not only configure the test bench, but also pick the games and then look at the data. Speaking of a team effort, Brad Charkis has also gathered all this information, and he is writing up a review as we speak. So after you watch this video, be sure to go read Brad's review over on the website. There's a link in the description. So Will, thank you for helping me with all this testing. I couldn't have done it without you.
It's always a team effort here at PCWorld. I, however, am just excited about this card because it's occupying a place that we haven't seen like exciting things happen in a while. The $250 price point has been filled with despair and sadness for just a minute.
Speaking of which, we have a whole host of cards that we tested against this one. All of them somewhat around that $250 price point, but they all come in definitely different configurations. So let's go over those before we start, and then we'll get into some of the actual experiences of using the software, because I think a lot of people are very confused or curious to see how Intel stacks up in that, and then actually get into the actual benchmark numbers, which we have for content creation, gaming, power, all that kind of stuff, and then finish up with our thoughts. So first up, let's talk about the GPUs. So of course we have the Intel Arc B580. This is the limited edition GPU that, we'll see how limited edition this is. There will be partner cards available as well, but we do not have our hands on any of those. This one clocks in at $250 even.
It's the kickoff card from Intel, and it's what, a 12 gigabyte card?
12 gigabytes, yep, which is one of the highest capacity that we have on this table, which could be important for the gaming benchmarks. We will see when we get to those.
What else do we have here, Adam?
Well, up against the B580, we have Intel's last generation GPU based on Alchemist technology. This is the Arc A750 limited edition. Now, even though the naming is a little bit different, this is coming in at that same $250 price point, so thought that was kind of the best comparison.
Apples to apples,
gen
as
over
you
gen.
were.
Yeah, on the Nvidia side, we actually have 3 GPUs.
Okay.
The first one is the GeForce RTX 4060. This version specifically is the Gigabyte RTX 4060 WindForce OC edition. So this one actually clocks in more than the $250 price point, but it is the lowest edition of a desktop GPU you can get in the 40 series line. So we wanted to include it, even though it was a little bit more, usually around like $400-ish.
Closest current generation comp for Nvidia is the watchword there.
Exactly. So to bring something that's a little bit more price competitive, that is still actually available on the market, we have the RTX 3060. This specific version is the MSI Ventus 2X 12 gigabyte OC edition. Now this one, even though it's last generation, this one actually clocks in closer to that $250. It's around $260 on the street currently.
And I assume that OC doesn't mean Orange County, but that it's overclocked?
I mean, supposedly, that's what they tell me.
Okay.
So, yeah. Also, just for fun.
This is kind of the wild card, right?
Yeah. We decided to throw in a GeForce GTX 1080 Ti, the highest end GPU you could get at that time.
Some people have said it's the greatest video card ever made.
So, some people said that. Yeah, we'll see. And I did think at first, I was like, well, this is kind of a weird comparison because that clocked in at $700, but you can actually buy 1080 Ti's right now for lower than $250. I actually picked one up that's getting delivered today, which is a Founders Edition card for $200. So you can still get that card. It still offers good performance. I mean, I guess we'll see in the benchmark charts, but I thought it'd be kind of interesting to throw in something to say, hey, what is the high end of previous years? How does that compare to what we have today at $250?
Well, it's also interesting because one of the targets for benchmark performance that Intel actually talked about was the GTX 1060. Same generation, a little bit less capable card. But you know, I'm interested to see how a really, really fast card of yesteryear performs against modern lower end hardware, frankly.
And last but not least is an AMD card. So this is the RX 7600, specifically the XFX Speedster Swift 210. So this one does come in at $250. So it is a pretty fair comparison comparing AMD to Intel here. But this one only has 8 gigabytes of VRAM. So we will see how it keeps up.
So mostly 8 gigabyte cards. The exceptions are the ancient 1080 Ti
with 11 gigs.
The 3060 with 12 gigs.
Correct.
And the new B580 also with 12 gigs.
With 12 gigs, yeah. And so, you know, we will see what that looks like in the benchmarks and how much VRAM capacity is kind of playing into that. But first, let's go over the actual test bench specs. So we configured the test bench to make sure that we took out all of the bottlenecks that weren't GPU bound. So for CPU, we have one of the best performing CPUs we have out there right now, which is the AMD Ryzen 9 7950X3D. So really good, capable CPU still. It was slotted in an Asus ProArt X870E Creator Wi-Fi board with 32 gigs of Patriot Viper Venom DDR5 sticks running at 6,000 megatransfers per second. We have a Gen 5 Crucial T700 NVMe SSD in there. So yeah, the test bench, we wanted really high-end stuff, really stable stuff to try to take out you know, the actual any sort of bottleneck that wasn't GPU bound. What
about Windows, Adam?
Well, we were running the newest version of Windows 11, 24H2, specifically 26.100.2454. So a brand new version of Windows from earlier this month. VBS was on. Power profile was set to the best performance. Rebar was on. The iGPU is also disabled, and then also in the BIOS we have PBO enabled. So we're getting the most out of that. So Nvidia used all of the same driver, which was the 556.36. AMD used 24.10.1. The A750 used the driver 6299, and the B580 was a pre-release driver provided by Intel, which was 6249.
Okay, so that's all the housekeeping.
Yep.
What was it like using the actual card?
Yeah, so apart from the actual benchmarks, which we can still get to, which is, you know, very stringent testing, I did want to throw this in a system just to see how it ran, right? So there is a new version of the Arc Control Center. Now they call it the Intel Graphics software kind of thing. So brand new software, and to tell you the truth, I had no problems. There was no weird hitching. There was no weird full screen issues that I ran into. It doesn't mean there might not be something out there, but it was rock solid. I appreciated it.
So this is just to contrast with the Alchemist launch a few years ago. Mm-hmm. Those drivers were, I don't know, rough is probably the generous way to say it.
Yeah, that software was bugging out. I mean, it was missing features, all that kind of stuff. I will say this new software is missing one feature that I thought I was missing somewhere, but it does not, in its current iteration, have any sort of quick overlay that you can enable to kind of see performance. Intel tells me that they will be bringing that back later, but so that was one weird exception. But this is, you know, a ground-up redesign of the software, so hopefully that will come in at a later date.
Did it feel like early software when you were using it, or does it feel pretty mature all the way through?
No, this felt pretty damn mature with a lot of good tools in there. I mean, we didn't get too much in, you know, testing like undervolting and things like that, but all the tools were in there. It was snappy, and yeah, that was a real contrast compared to the Alchemist launch. And I will say some of this is probably because they've done so much of this same work over on the mobile side, right? This is the same XE architecture that's you know, available in Lunar Lake, and we have seen lots of updates. I mean, here on PCWorld, we even did a monthly update thing at the early launch of Alchemist just to kind of see things grow and mature. And I really do think we are at a place where things are relatively stable from the actual software experience itself. So I was pretty happy.
So one of the other things they added with the new software suite is, and the new range of cards, is a second generation of the kind of XeSS upscaling and low latency and frame generation tools.
Yeah. Which packaged together they're calling it XeSS2.
Okay.
So yeah, it's a new generation of that. The upscaling is a part of it, but like you said, they're including the low latency mode and then now frame generation as well. I will say at launch, there was only one game pre-release that they gave to us to test, and I ran out of time, and we actually didn't end up testing it, to do any performance testing or even like quantitative, like how does it look kind of testing. So that is a bit of a bummer, but I mean, I think we're glad to see those things come, right?
I mean, we're in a situation where there's parity now between Nvidia, AMD, and Intel on these things. They all have AI upscaling. They all have frame generation. They all have low latency, so that the frame generation is actually playable. So we talked to Tom Peterson a couple weeks ago on The Full Nerd, and we talked about the impact of each of these technologies. And while I think you and I are maybe a little bit up and down on frame generation sometimes, although it's interesting at this kind of price range for this kind of part, the low latency and the upscaling together provide some real benefits in terms of performance and evening out frame rates that I think are worth investigating. I think we don't have anything concrete planned, but I think we should investigate that further as we get a little further down the line.
Well, and I mean, we'll see how it's adopted as well. I would say one downside is that now this XeSS2 package is now locked to Intel hardware. It requires those XMX execution units to fully run, and that's opposed to XeSS1, which was just the upscaling tech. You could run that on any GPU. Yes, Intel had a kind of a superior version of it because it was running on the Intel hardware, but it did have a fallback version that you could still use on any GPU, which was nice, but XeS2 now is locked down to just Intel hardware.
But it's not just Intel discrete graphics, it's anything that has the Xe graphics internally, including every laptop that runs Lunar Lake that they've sold so far this year.
And Meteor Lake. Yeah. And the first generation Alchemist, yeah.
Which means that their installed base is enormous. I think that hey, we're going to make this open to all GPUs was an initial launch stopgap to get people to support the software when there was a relatively low number of GPUs in the world. Now that we're looking at millions and millions and millions of units shipped, it's a little bit different story. And as somebody who has worked as a game developer, it makes sense to me to support each of these products from the different platforms. So anyway,
so I do feel like there's a little bit of an asterisk around XeSS2. It's still early days, more testing to come. We will come back and talk about it at another date.
Yeah, I was gonna say, what about your experience playing games?
Yeah. I mean, other than just benchmarking, I did load up some of the games that I've been playing recently just to kind of throw it in there and use it as a normal user. So I threw this in my small form factor work rig. I don't really do gaming on it, but that was kind of the easiest thing to throw it into just to kind of have a point of comparison. And this was running a 7900 non-X CPU, loaded up the drivers, downloaded Steam, downloaded some games, and honestly, just to tell you, I didn't run into that many problems. This was a clear night and day. Is Arc gonna work on this game or not? For the most part, it worked, and for the most part, I had it running at 1440p. All these games with somewhat high settings, and but I did rely on at least a touch of upscaling. Okay. So I don't know about you, but even on the higher end hardware, when I do game on that, I like to use at least a little touch of upscaling. So it kind of depends on what you like and what you do, but I do feel like I was able to get a good experience out of this.
So I almost always turn on a little bit of upscaling, usually on the quality setting, so it's the minimal upscale. But it turns out it smooths out those 1% lows and the minimum frame rates, so you get a little bit less of the stuttering at places where the game and the system are struggling.
Yeah.
What games did you play, Adam?
So Baldur's Gate 3, I've finally been diving deep into that, and unfortunately I'm very sucked into it. So that ran awesome.
We'll see in a few hundred hours.
Yeah, right. I did play Silent Hill 2, one of my favorite games of all time, specifically the remake. That is heavily reliant on RT, so I definitely got to turn on some RT effects in there. And for a game like that, I'm okay having lower frame rates, like 30 or 40, smooth 30 or 40, just so that you get all the bells and whistles in a game like that. That's how I like to play it. But I was running once again at 1440p with RT and having a smooth experience with it.
Look, I think a solid 40 frames a second with ray tracing on in a single player game, totally acceptable these days.
Yeah, I like it.
And this is all at 1440p as well.
Exactly, yeah.
Okay.
I did load up some brand newish games like Stalker 2 that just came out. Obviously that has a bunch of its own bugs in there, but what little I did play, was perfectly acceptable. I'll say I definitely did have to dial down some of the settings because that one is so intensive, but that could have just been my hardware configuration in general.
On higher end GPUs, that game tends to be really CPU bound. I don't know what it does on these kind of lower mid range parts.
Yeah. So I did run into a couple problems.
Okay.
Really small asterisks. So I did try to load up Star Wars Outlaws because I actually haven't played it and I was curious. And after the intro cutscene, when it would come into the first controllable area, it would crash. And I was like, okay, I'll come back to this. I don't know if there's a problem with the game, which I've heard is really buggy, or if maybe the drivers or something. Lo and behold, Intel emailed later, apropos of nothing, and been like, oh, hey, we have a new driver version, and by the way, it fixed Star Wars Outlaws. They got to this fix for this GPU before even the launch, which was nice, so I did end up playing some of that, and it was great. The other brand newish game, literally hot off the presses, was the Indiana Jones and the Great Circle. So this one, I ran into problems. I actually couldn't get anything configured correctly to get performance of like acceptable performance at all. I mean, I was literally cranking it down to like, sub 1080p, and then all settings on low and all that stuff. And yes, this game uses, from what I understand, maybe correct me if I'm wrong, but it uses mostly RT to do all of the rendering anyway, so there's no way to make it fall back and not do RT. But I mean, this is an RT capable card, so something was amiss there. I didn't have time to like test it. I didn't ping Intel about it, so I'm not quite sure if it's the game or if it's the actual pre-release driver. But that was one where I was like, ooh, okay, I ran into some problems there.
Yeah, Indiana Jones and the Great Circle has incredibly high minimum specs. It's a kind of powerhouse game. Everyone I talked to has had some sort of trouble running it. I was out of town, so I haven't actually loaded it up yet to see what the story is. So I'm not surprised that they had problems. Did you ask them to see if Intel has a comment on what's going on with it, or are they just silent unless there's a specific fix for a game?
Yeah, I didn't ping them specifically about this one, and it's not officially part of our test suite. And I mean, it is brand new, but once again, it maybe kind of points a little bit to some of those same teething pains of like, hey, a brand new day one release of something, Intel might be a little bit slower to the draw. But this is a new architecture, new drivers.
It's a new architecture, it's new drivers, and the card's not available yet. Also, so like,
True.
it was a real weird situation to have a game come out in between when we received the test card and when the card actually releases.
Yeah, that doesn't happen much.
That's high profile, and like I wouldn't have probably asked about this on an Nvidia or an AMD card just because they have a long history of dealing with day one games.
Yep.
Since Intel had some problems with that on the last generation, I think it's interesting to see. And I would say if you're curious, keep an eye on their driver updates and see when they dump a patch note that says, hey, by the way, perf on Indiana Jones is right up your alley now.
I mean, speaking of that, even through this review process, they were patching games, finding things that I'm sure reviewers were running into. So they were real quick to the draw, and I would say that's how it's been for the past number of months with Alchemist as well. Where yes, there were outliers like Starfield that literally just was a disaster in terms of having a launch and you literally couldn't run it on your Alchemist card. But I see less and less of that, and they are very quick to get to the draw. So I appreciate that, but it still has a little bit of those caveats. I feel like if you are a day one gamer, that is where you should maybe still give it a little bit of pause.
Maybe think about it.
But for the most part, I think only weirdos like me kind of like love to like play a game right at launch, even though it's traditionally not the best time to do it.
So Adam, how did this perform in the benchmarks?
The benchmarks. Yes, the official PCWorld benchmarks. And I will say for official benchmarking, we do an average of 3 runs. Everything is tried to be as evenly put as possible. And we kind of went through each different game to configure in something that we would think that would be the best test case, right? And try to be fair and equal to all of the vendors so that we're not just like trying to dogpile on one or the other. Yeah. So, I mean, it is something we are constantly working on, and And hey, there's GPUs that should be coming out in the near future. So if you have any games that you would like to see added or ways that things are configured, definitely let us know. I'm definitely taking the feedback on that.
Yeah, I think the big changes this go around is we are reporting 1% lows or minimums or 5% lows, depending on the games, where the benchmarks provide them, which is, I think, important these days, because as we're seeing frame rates go higher and above what you're going to probably have a monitor that supports showing in a lot of cases, those stutters are the things that we feel as performance hitches now, more than just the low frame rates.
Yeah, and how we present it on the chart itself, because I'm still learning how to make nice charts in Excel, is that I actually like to lock the GPUs in place rather than shuffle them based off of performance.
Yeah.
Because then you know, oh hey, the top two are Intel cards, the next three are Nvidia cards, and the one at the bottom, not intentionally, is the AMD card. Just so you know, at a quick glance, they're always going to be in those spots, and then you can kind of look at how each one performs.
So then how did we handle the vendor-specific stuff like upsampling and reflex versus low latency and frame generation?
Yeah, so unfortunately, like I said, XeSS2, the low latency and frame generation stuff was only available in one game. We didn't get to test that, so we only used upscaling in some of these test case scenarios. And when we did, it was when we enabled RT features as well, because we wanted to have some RT in there as well. But we locked it to the same resolution equivalent. So even though each one of them might have a different way that it's called, it is always going to be the same resolution upsampling, and then we used each vendor-specific option for that. So for Intel, we used XeSS, for AMD, we used FSR, and for Nvidia, we used DLSS.
But going from, say, 1024 by 768 to 1080p in each case, because we know what the starting resolutions are.
Exactly. So first up, let's start with the content creation benchmarks. And the first one we have is Adobe Photoshop 26.1. That is tested with the Puget Bench, which has a built-in kind of run that it does. Takes things through different filters and cropping and resizing and exporting and all that kind of stuff. Spits out a nice clean number. And what we see here is not much of a difference, to tell you the truth.
I mean, the 4060 suffers a little bit, I think, but it's not. It's like 10%, 8% or something.
Yeah. I will say that this actually is traditionally more of a CPU bottleneck. Even Puget Bench says on their website that even though they do have GPU accelerated features in Photoshop, most of the time it's still waiting on the CPU. So the CPU is the bottleneck here, which is why we're not seeing too much. So there's not a ton to take away from this, other than the fact that if you're somebody who uses a lot of Photoshop, you can use the vulnerable GTX 1080 Ti and still get a damn good experience.
Yeah, it's not a huge surprise here.
No. Yeah. So let's get into something that has more of a GPU bottleneck, and this is Adobe Premiere Pro 25.1. Once again, tested with Puget Bench. I used the standard test rather than the extended for this one, which it just kind of takes out some of the high-end 8K footage and things like that.
Okay.
And for this, we can see that Intel is clearly on top compared to any of the other GPUs, which is interesting because for the most part, for video editing here at PCWorld, we do use Adobe Premiere Pro, and we do tend to use Nvidia GPUs. So this is something that kind of scratched my head a little bit. So I had to dig into the subscores to kind of see where we're seeing these performance differences. And the first one came across the compression formats, long GOP versus intraframe. And if you're not a video nerd, just know that long GOP is essentially taking a grouping of frames with a keyframe to make smaller file sizes out of it, where intraframe is actually compressing every single frame, but the file sizes are very large.
Okay.
Both of them need to be decoded in real time when you're, if you're editing off those in real time, which can be, a resource hog for sure. So whatever, a lot of nerd speak here, but to get to the bare bones of it, if you shoot in long GOP, which we do here at PCWorld, you're watching this video recorded on long GOP, then AMD has the inherent advantage over both Intel and Nvidia, which I was very surprised. Nvidia has a inherent advantage in raw file formats, which Okay, that's cool. I don't use a ton of RAW. I don't know a ton of people who do use RAW, but if you do use RAW, then you probably want to, maybe look at NVIDIA GPUs. Where Intel shines, both on the Alchemist card and the Battlemage card, is interframe. So that is, the larger file formats.
Less compressed.
Exactly, yeah. But then also the GPU effects. You can see the list of the whole GPU effects that it tests over on their website, but in those two areas, the Intel cards had the inherent advantage. But surprisingly enough, neither the Alchemist or the Battlemage necessarily had an advantage over the other. I would say this is within margin of error, and they both turned in a pretty good score.
And this is a bigger bar better.
Bigger bar better, yes.
Okay.
And the last content creation benchmark that we have here is Blackmagic's DaVinci Resolve, specifically 19.1.1.8. So this is the newest version, once again tested with Puget Bench, and this is a standard score versus the extended.
I'm noticing something here, Adam.
Yeah, that's a big fat 0. And this is something that I kind of had to dig into for a while. I wish I had more time to really figure it out. I did talk with Intel. We were going back and forth on troubleshooting things, but I could not get this new Battlemage card to finish a run of this DaVinci Resolve test at all.
Is that common in your experience with this Resolve test?
No, and it was seemingly hanging up specifically on a couple plugins. One of them was temporal noise reduction. So the thing is that I will say, caveat, I didn't have the time to dig into this and really figure out, is this something that is an Intel problem? Is this something that Puget Bench has a problem? Puget Bench has reported some problems with this test, so I wish I had more time to dig into it. Intel assures me that they were actually able to get this running on their test bed, so maybe there was something wrong with the way we had it configured. I don't know. Either way, it's kind of a bummer not to get a score, and it is something that we do have to call out because we didn't get a number.
Cosmic rays.
Cosmic rays, but if you're wondering how the other ones shake out, because this is kind of a weird layout of what you're getting here, Nvidia actually had the inherent advantage for intraframe compression, where Intel had it before, and the AMD card actually excelled it at long GOP. Once again, but also the Fusion score, subscore, I should say. So Fusion is kind of their built-in 3D rendering. It's kind of the same thing as Adobe After Effects, right? So you do 3D.
It's like GPU accelerated.
Very heavily GPU accelerated effects. But the Alchemist card did have an inherent advantage on intraframe compression and RAW. So kind of a reshuffling of how it was over on the Premiere bench, but yeah, it's an interesting test. Actually, I don't need to do this. But now, video games. People play video games. Do you play any video games?
I love video games.
I play some video games. Let's look at some benchmark numbers. And like you said earlier, not only are we reporting the average numbers, we also have included the minimum frame rates or the 1% lows. Where it's applicable, we will call it out for each test because they all kind of report something different.
For folks who don't know, minimum frame rate is just going to be the lowest frame rate that shows up in the run. 1% or 5% lows are going to be the 1% or 5% slowest frames that were generated.
Yeah, which is very important to see that information. I will say here at PCWorld, we like to use built-in benchmarks for all of our testing. And essentially, even though some of the games are not the newest, hottest games out there, we're looking at relative performance between the cards versus, hey, how do these perform in the newest games? But once again, we did try to pick a wide test suite of different rendering engines, different effects that it's processing, different types of games, things like that. So I think we're able to get a clear picture or understanding of how these stack up.
And just generally speaking, when you're looking at these numbers with the averages and the minimums or the 1%, the closer those two bars are, the better. Yeah.
Yep. So let's start off with a Ubisoft game, which is Assassin's Creed Valhalla. This was used with the ultra high preset, and there was no upscaling or RT involved. And you can see that we have the 1080p and 1440p averages and 1% lows in here. First up to look at is the Battlemage over Alchemist, and holy hell, I don't know what you think, but going from 67 average to 101 at 1080p is pretty damn good.
It's pretty good. Like, the interesting thing about this to me is that this is giving great performance at 1080p and entirely playable performance at 1440p without any upscaling or anything like that, which is like, that's what you want, right?
Yeah.
This is the ideal. It's a great generation over generation improvement in performance.
Yeah, and you know, if we add in the rest of the GPUs here, we can see that from Alchemist clearly being behind all the other GPUs to now Battlemage hopping up and playing neck and neck at 1080p and 1440p with the other GPUs. At 1440p, it does have the bigger bar better for the averages.
Yeah.
And at 1080p, it's playing up there, and you know, right at 100 frames per second. So you know, it is comparable to say a 4060 or a 7600.
Now, the thing I will say is the delta between their average frames and their 1% lows is not quite as good as the 4060.
Yep.
At 1080p. At 1440p. Basically the same.
Yeah. So maybe that's an indication of the higher VRAM playing in there.
It could be more VRAM. It could just be driver instability. It could be anything. Like, the number of things that can stall out that 1% low frames to cause that. It could be something that has nothing to do with the video card. Everything else in the machine is the same. You know, so it probably is something to do with the video card or the driver or some library that lives between the video card and the driver and the game. Mm-hmm. It's really hard to know exactly what causes that on a moment-by-moment basis. But like I said, generally speaking, you want the two bars to be as close as you can.
Yeah, and we don't need to hammer on it too hard, but if we're talking about wide gaps between averages and 1% lows, that GTX 1080 Ti is not looking too hot.
This is the difference. You know, this is a 7-year-old card, 8-year-old card at this point. So it's an old piece of hardware.
It is, yeah.
I'm guessing that probably driver optimization time isn't spent as much on 1000 series cards that are 4 generations old now. Yeah. But yeah, like, the reason you don't want to use it, the reason you want to upgrade from a 1080 Ti, a high-end $700 card at the time, to a $250 card today,
potentially,
is that your 1% lows will be much higher.
Yeah. All right, let's move over to another game. This is a newer game, Black Myth Wukong, that does have a built-in benchmark. We ran this at the medium preset with no upscaling in RT, and wow, this is definitely a very intensive game to play across all these GPUs. And even though we do see a bump from Alchemist to Battlemage, this is one of the games where Battlemage just is not necessarily keeping up with the high end of the pack. Do you have any indication of why it might be behind?
It could be a lot of things. Wukong is an expensive computational render. There's a lot of stuff going on, so it could just be something as simple as they're using different pathways that don't exist, that are accelerated on AMD and Intel. That are accelerated on AMD and Nvidia, but Intel is running like in a less computationally efficient way. It's not memory bandwidth. That was my first thought. Memory bandwidth if we're ranking these by the memory bandwidth available, the Arc A750 is the highest, followed by, oddly enough, the GTX 1080 Ti, just because it has a really wide memory bandwidth compared to these $250 cards. Mm-hmm. And then you're looking at the B580, the RTX 3060, and then the 7600 and the 4060. So, like I said, probably it's just configuration, how the Black Myth Wukong developers are actually using the shader units or compute available in the GPU, not, there's nothing obvious.
So this was one game we wanted to include that runs on Unreal Engine 5, which is, a very large engine. Would you be concerned that Intel has an inherent disadvantage in that popular engine?
Not really. The way modern game engines work is the developer can use the thing that Epic ships, or they can rip all that out and write their own thing. I don't know what the folks who made Black Myth Wukong have done, so it's difficult to make broad generalizations about how this is going to impact all UE5 games just by looking at one benchmark in one game without knowing what's going on under the hood.
Okay, I will say that Intel did provide a driver update that improved performance, but specifically only in RT. We did not test RT here because I felt like this game was already computationally intensive, even without RT. So, Intel is looking into it in some of these performance things. So, once again, good on them for following up, but.
And the thing I'll say here is that if you look at the delta between the average frame rate and the 5% lows, it's not a big split. So even on these $250 cards, you're getting a really playable frame rate pretty much on everything here, including the 1080 Ti at 1080p across the board.
Yeah, yeah. So.
Yeah, I was gonna say the other thing about this is also a game we don't test with upscaling on just because I think this didn't support XeSS, right?
Yeah, this only had Nvidia DLSS available to it, so we didn't.
For me, this is a game I would play with upscaling on and turn everything all the way up to get that the most graphical juice I can.
Yeah, for sure. Well, moving on to the next game, we have Call of Duty Black Ops 6. This was ran with the Ultra preset. The VRAM target was set to 80%. Variable rate shading was set to off, and we used no upscaling or RT. RT isn't available in here. We have the 1% lows being represented here. First thing I wanted to point out is that 1080 Ti was the only GPU that I was running into problems and could not get. I couldn't get 1440p run at all. 1080p I actually only got one clean run out of. So kind of throw away those numbers. That seems to be kind of a weird outlier problem. But once again, maybe points to, hey, older GPUs, are sometimes going to have driver problems in newer games. Either way, we're seeing the same story that Battlemage is outperforming Alchemist, though it does fall behind the 4060 and the 7600, just like Black Myth Wukong.
Yeah, I think this is one of those situations where optimizing and spending more time on the drivers is going to show some impact, but I don't know. Like, again, we don't know what's going on inside these game engines, and we don't know why this game, the B580 is outperforming on a lot of games and underperforming on COD Blops and Black Myth.
Yeah, I actually did reach out to Intel for comments specifically on Black Myth and Call of Duty, and they said, yes, you know what, there are some games where they're just going to be behind. But once again, I think that's going to be true for every vendor. Every vendor is going to have some outliers. That's why on the chart, of comparing generationally, sometimes they have some that are below the line, sometimes that are above the line. They want more to be above the line, but there definitely are still some times where they're below the line, and this seems to be one of them.
It's unfortunate because this is a huge game that a bazillion people play, and it's also the kind of game that should be a strength for them in that a lot of people buy this, they're playing on low-end PCs, and this should theoretically be a big dub if they had the perf here for this.
Yep.
The thing I'll say again, graphics pipelines are really complicated. And it's entirely possible that there's more headroom here. This could also be it. So don't buy a card based on future promises or whatever. They didn't make future promises in this case, which I kind of appreciate.
Yep.
I'm curious to see what happens to this over the next 6 months.
Yeah. Moving on to the next game, we have Cyberpunk 2077. So we actually did 2 different runs, one without RT, one with RT. So first up, we're going to start off with the Ultra preset, but no upscaling and no RT. This only reports the minimum frame rates at both of these resolutions. And here we go. Look, bigger bar better. That Battlemage card is top of the heap when it comes to both 1080p and 1440p.
Yeah, the surprise here is that the Battlemage card is the only one that we're seeing 1440 numbers that are playable, I think. I know you like a smooth 40. I'm not here to judge 40. You for that. But if I'm playing this game and I'm not playing with ray tracing on, I want it to run butter smooth and I want it to look real nice. And this is impressive. 96 frames a second on a $200 card, $250 card in Cyberpunk, even with ray tracing off. Still, I mean, that's impressive.
Yeah, and once again, it's a turnaround from the last 2 games where we're seeing a very nice advantage with the Intel card for damn sure.
It's interesting to me the games we talked about that have released recently. COD Blops came out about a month ago now. The Indiana Jones game came out a couple weeks ago. Star Wars just had a huge patch a few weeks ago. These cards aren't widely available, right? I'm sure that they've been seeding them with developers over the last 6 months, but for the most part, unless you're a huge developer and you've actively engaged with Intel, because you want to be able to play your games on their laptops, probably, they're not out there. They've clearly done a lot of work on Cyberpunk and worked with the folks at CD Projekt Red. So, they should be excited about this. This is a good number.
Well, should we also be excited about ray tracing performance in Cyberpunk?
I'm really curious. This is the thing I'm most curious about, Adam, is can you play ray traced games on a $250 video card? Well,
let's give over to those results. And once again, we see the B580 at the top of the heap. Not as big as a difference compared to the 4060, But also, that B580, I'd like to remind you, is at least $50 cheaper.
$50 cheaper, yeah.
So yeah, you're talking about turning in, those are some respectable numbers at 1080p, even though we are using upscaling, you know, we are using the RT Ultra preset, which is enabling all of the bells and whistles. Sure, it's not path tracing, you know, the full hardcore mode, but this is a lot of ray tracing going on here.
Yeah, this is really impressive. I think, I mean, realistically, I wouldn't expect to turn path tracing on anything other than a $1,000 plus video card. It's incredibly computationally expensive.
Yep.
And these little cards, they're incredible performers for what you're spending money on, but they don't have the same juice as a card that's going to take 600 watts and turn it into some amazing pixels.
Yeah.
Like, this is the place. I just gave you grief about your smooth 40 a second ago. A 43% minimum frame rate on Cyberpunk with ray tracing on a $250 card, that's magic to me.
Well, and I would also say that maybe this, even if you prefer rasterization with higher frame rates, this at least allows you to realistically play a bit and just kind of see what this whole RT experience is like at this price range, which I think is pretty important. And you know, of course, I do need to point out that the GTX 1080 Ti, there was not even an option. I couldn't even. There was literally no option in the menu for ray tracing. It was
we didn't have
so
ray tracing was just Pixar movies at that point, you know, way back then.
So moving on to another game, we have F1 2024. This was on the Bahrain map. This was a high preset, so no RT and no upscaling applied. This is something that we're going to see a lot of really high frame rates set at. And looking at the numbers, actually here, the AMD card has the bigger bar better. So I would say that no matter what, all of these at 1080p are over 120 frames per second. But if you're really trying to juice the most out of it, that AMD card wins here. But once again, we are still seeing a nice jump from Alchemist to Battlemage. That continues to be the trend here.
And also, I'm going to point out 1440p eminently playable on Battlemage, on the 4060, and on the AMD card. Now, the tell here, look at these mins. Look at the mins at 1440. This is when the 8 gig cards start struggling, right? The minimum on this RTX 4060 is 68 frames per second, which is, I mean, that you're going to feel that one. Whereas the delta between the average and the minimum on the 1080p, on the 580, even on the 1080 Ti are much lower than that. And yeah, so 8 gig card, 1440p, maybe not what you're looking for exactly.
And I will say once again that this is an average of 3 back-to-back runs. It's not like there was one of those 3 numbers on that 4060 that is pulling down the average.
Yeah.
All 3 of them, I'm going to read them off right now: 69, 63, 73. So
nice.
This was consistent. This is not just a you know, kind of a one-off that's dragging those numbers down. This is consistently getting hit with those 1% lows, or I'm sorry, the minimum of frame rate.
Yeah, I mean, look, this is Intel's backing up the promise that they made here that you can have 1440p on a $250 card, which is cool.
It's true. I dig it. Let's keep going. Here we have Returnal, which we tested both with rasterization and RT. This one does not have a super heavy RT implementation compared to Cyberpunk, but it is one that we wanted to test out because I think it's interesting, and the benchmark is actually pretty intensive as well.
Well, it's also a PS5 launch title, so it's a PS5. It's a game that was designed for current gen consoles that's been ported over to the PC. And while every game is different, every pipeline's different, yada yada, it is indicative of what you could do, you know, when we were starting this current generation with the early ray tracing hardware, not necessarily in this run of the benchmark. So anyway.
Yeah. Well, for the first run, we have the Epic preset. Once again, no ray tracing, no upscaling, and Intel with that B580, boom. Not only is that a big win, that is a very big win.
Both in the minimum frame rate and in the averages. I mean, I'm a little concerned about the gap between the average and the minimum. The minimum's usually gonna have a bigger gap than the 1% low, just because you're seeing fewer, you know, you're comparing one frame instead of the 1% slowest frames. But this this is all playable. I would play this.
Yeah.
Clear win for the 580.
Well, turning on ray tracing and upscaling, but no frame generation. We switch over here and once again see that the Intel card has the inherent advantage, but we get a big hit on that 1% low.
Yeah, it's at
1080p.
It's a little bit disappointing. I mean, I'm seeing a similar jump. It's like half the frame rate across the board, pretty much. The AMD has a much bigger dip, all the way down to 25 frames a second on the 1080p one minimum, which is from 72 to 25. That you will 100% feel. Look, it's a third-person game. I feel like sometimes, especially early console generation games, it's hard because often they're building the game without having the hardware available, and then you end up in this weird situation where you have to make some choices that may not make it viable for a port down the line, or you're creating problems for future you that you may or may not solve.
Yeah. Well, speaking of creating problems, we wanted to throw this one in here. I do want to say that this benchmark for Senua Saga Hellblade 2 is not an actual run-based benchmark. What they do is that you go in the graphical menus, you set them, and then it's actually rendering a scene behind it. You can hit spacebar and it actually minimizes the overlay, so you can kind of see what the frame is being presented. There are no minimums that we're reporting here. It just has an average, and I just kind of let it sit there for a while. Yeah. So, like this isn't the cleanest benchmarking, compared to the other ones here, but I thought it was kind of interesting to load up and see. And what we see here is that, it looks like, we've got two groupings here. We have the B580, the 4060, and the 7600 in one group, and then the A750, the 3060, and the 1080 Ti kind of in the other group. So, I don't know how much it's saying here other than that the game is very resource intensive. But either way, Intel is holding up in a game that had a lot of fanfare at launch, but did not really light the world on fire.
Yeah, I mean, I think again, it's hard to know what's going on here without looking into the pipelines and knowing more about how the games actually work. My guess is that this is a compute, like more compute on the newer cards, on the 7600, the 4060, and the 580. And less on the older cards would be my guess.
Yeah. We do have a couple games, popular games, left to get to here. Next up is Tom Clancy's Rainbow Six Siege. This was run specifically in DX11 mode because we wanted to test the DX11 capabilities here. And once again, we only get the minimum frame rates here reported, and across the board, Intel hangs with the B580. I mean, we're talking about over 300 and change.
Yeah, they're in the same
1080p.
In the same range as the 4060 and 7600. Their minimum frame rate is a little bit lower. Mm-hmm. Again, you just mentioned this. I'd rather have 1% lows. I feel like minimum is you get weird outliers and strange results. This is this is a perfectly cromulent set of performance numbers for this card at these resolutions.
But once again, we are seeing that same trend that the B580 is handily outperforming the A750.
On two levels actually, because this is the DX11 pipeline through Siege. Mm-hmm. When the Alchemist cards launched, they had enormous DX11 performance problems.
Yep.
So we would not have seen 277 frames per second from the A750 at launch in DX11. No. So it's a remarkable jump from the launch of the Alchemist cards. It's a remarkable jump generation to generation using today's drivers. So yeah, it's good to see.
Yep, I like it. And the last game that we have here is Watch Dogs Legion. So this one we ran a little bit differently. This does have RT reflections that you can turn on, but I actually ran just one run with those RT reflections because it actually wasn't too computationally intensive. And also, I did not use any upscaling because this was a game that only had DLSS available to it. So I was like, okay, could these GPUs run an RT game without any upscaling, even something that's not as intensive as like a Cyberpunk? And here, you know what? You actually can. At 1080p, I mean, we're getting an average of 61 frames per second, but that does fall in line with the 4060 as well.
And it's important to note with Watch Dogs Legions, this is one of the first ray tracing compatible games. It came out a long time ago at this point, and it has by today's standards of relatively soft ray tracing implementations. It's just reflections. So things like puddles and windows, there's no lighting, no ray trace. I mean, there is lighting, but there's no ray trace lighting, no ray trace shadows, which are computation more expensive because they impact every pixel on the screen instead of just the ones that are tagged as shiny pixels.
Yeah, well, and surprisingly, the AMD has an inherent disadvantage in this game, specifically, definitely turning in bad numbers. And you might be curious as why we're getting numbers for the GTX 1080 Ti. There are games out there that you can enable ray tracing on these older GPUs, and this is one of them. I was very surprised to get these numbers. So I mean, you know, theoretically, you could get ray trace reflections on your 1080 Ti as long as you're okay with a smooth 30
or a smooth 22.
But that's it for the gaming benchmarks. Let's move over to the last piece of testing we have, which is power consumption. And for this one, we did F1 2024, but we set everything to 4K to really stress the hell out of these GPUs and really you know, try to get as much juice as we could out of them.
Yep.
So for this, I actually started capturing from the desktop. So we're going to see kind of idle performance, and you're also going to see me launch the game, go into the menus, hit the benchmark. That's kind of, you know, where we're going to see most of the power consumed there, and then actually ending the benchmark and exiting the game back to the desktop. So if we switch over to the chart here, we can see the 6 GPUs. On the left side, we have it idling at the desktop, and then this big run here in the middle, this big solid piece, is where the actual benchmark is running. So first up, let's look at the benchmark itself, and that green line is at 1080 Ti, and holy hell, that is over 400 sustained watts, and that's at probably like 70 watts higher than the next card down.
So it's worth mentioning this is total system power. We don't have a way to isolate the GPU power consumption.
Correct.
But because all of the runs are done on the exact same hardware, configured exactly the same way, you can extrapolate out that the differences in these lines are
just
the differences
GPU.
in the power consumption because of the change in GPU.
Yeah. So if we take out the 1080 Ti out of this equation and look at the next bar down, we see that A750. It definitely consumed a lot more power than the other ones. Not as much as the 1080 Ti, but it was at the top of the heap. And we look at the next two groupings down, and then we see that both the B580 and the 4060 are actually neck and neck. They're right there.
So while the benchmark's running, they are absolutely neck and neck. The idle performance difference was surprising on these two.
Yeah, you know, and I actually did have a lot of people in our Discord ask about idle power. And unfortunately, it looks like if we look over at the left side, both the B580 and that A750 are idling at a higher power consumption compared to the rest of the cards, which kind of drop down in the pack.
This is really surprising to me because these are the Xe cores that are shipped in Meteor Lake and Lunar Lake. They're mobile cores that just have a lot more compute units and a lot more capability than the mobile parts in these desktop parts. And I would assume that they would idle down to a lower rate than the more desktop-oriented parts.
Yeah, so I mean, maybe we're missing something here, and the configuration of the test bench that we had does not favor, you know, the Intel GPUs. But hey, you know, we try to keep everything the same. We didn't change anything. You know, just because we had a different card in there.
This could be a maximum performance in Windows. That does have different effects on mobile devices than it does on desktop devices typically, but anyway.
It could be. At least under full utilization, we can see that, you know, it is dropped down to that 4060 levels, though it is not as efficient as the 3060, which is at the very bottom of that pack.
Or the 7600, which is kind of splits the gap.
But that is it for all the testing. The charts are done. All we have to do at the end here is give our final thoughts. And when we came in here, you hadn't seen really the benchmarks that I'd run.
No.
Until we came in here to record this, and you asked me, you were like, "Hey, listen, what's your overall thoughts? What are you feeling about this?"
I needed an Adam vibe check.
Yeah, vibe check, and honestly, I'm feeling pretty damn good. You know, when Alchemist launched, there was a lot of driver problems. There was a lot of game compatibility problems. The power consumption, you know, seemed really high comparatively. And I think the general consensus was this is a good card for people who are okay with tinkering okay that understanding that you might have to wait for driver updates and things like that, that it's probably not for a normie that you would give. This GPU, I actually feel like I would have no problem recommending this to a normie. There are always going to be caveats, and I think what we're getting into now, though, is caveats that are dependent on each vendor, though. So while there still are caveats like, you know what, maybe some day one games are just going to horribly underperform, I think there still will be those outliers. There are caveats with other cards as well. Like if I'm recommending an AMD card, I'm going to say, hey, ray tracing performance, definitely not the highest of the pack here, right? Or a caveat on GeForce is that, hey, I mean, for the same performance, you're probably paying more to get that, and you're probably getting less VRAM as well. So like I feel like that's a better place than Intel was with the Alchemist launch because those are just kind of normal caveats that you're going to kind of trade around.
Well, after going through the numbers too, the 1440p numbers are consistently like pretty impressive on this card, right? I think where the 4060 is squarely a 1080p card that can play some games at 1440p, especially if you're going to turn on DLSS and upscaling frame generation, stuff like that, like you were getting playable numbers on almost everything you tested at 1440p without doing XeSS on this 580, and that seems pretty amazing to me for a $250 part.
And yes, and obviously in the marketing materials, Intel very much leaned into 1440p. So I was worried about 1080p performance, but that doesn't seem to be a problem. 1440p is obviously where a lot of people are going, and for $250, I mean, for the most part, you can definitely get there, and that is good. That is a good place to be in, and especially with that 12 gigs of VRAM, it should be able to hold its own, for future titles as well.
Now, you talked about caveats.
Yep.
It seems like if you buy a lot of day one games, you might be safer going with Nvidia or AMD.
Yeah, I would say generally, in the past, I think Intel has gotten way better about it. But I mean, we saw what happened with Starfield. I ran into it in Indiana Jones. There might be edge cases, right? So like, I think that's the caveat I would give is like, hey, if you're somebody like me who just loves to play games, right at launch, you're already playing with fire, but you're probably playing with a little more fire with Intel. But I think the major caveat of the software experience and all of that, kind of DX11 performance and things like that is pretty much wiped away. I mean, I'm sure there are things other reviewers are going to find, but for the most part, I feel pretty good about it. And I will also say that even though we saw leaps and bounds of changes and updates to Alchemist, I actually think we're in a pretty solid spot with this launch, meaning that we're not going to see in 3 months' time a huge email from Intel saying, oh, by the way, our DX11 performance increased by 50% overnight. Congratulations, kind of thing. So, like, I mean, not that you should buy on future promises, but I think that is something that's good to say, hey, you know what, I think it's stable now. They're not having to scramble and figure out a bunch of stuff on the back end. Yes, they need more developer relations. They need more, getting in with the games and especially getting like XeSS 2 involved in a lot of games. But, I feel at this point, they're pretty solid.
And looking at it from the developer perspective, they have a lot of XeSS games now, which I was pleasantly surprised by. I think it's going to remain to be seen how the XeSS 2 stuff rolls out, and whether that's a gradual launch as just new games get it added as they launch, or if we see some older games coming back in and getting in. The thing that really worries me is the COD number, honestly, because it's a big game. Millions of people play it every day. There's a bunch of people playing that on a wide range of PC specs, and I guarantee you, if you go to Activision, you ask them, hey, what's your most popular card? It's probably like a 2060 or a 3060. And if they have a real compelling upgrade story from 3060, 2060 to this, then that is a big deal for Intel and a place that they can sell a whole bunch of cards, which is good for everybody that buys one of these cards.
Well, and obviously the big elephant in the room of a major caveat is Intel not only the company, but the future of the graphics division. When Tom Peterson was on, he was like, hey, he's going to be honest. He can't talk about future stuff. The future is unknown for sure, but they are committed. They already have the XE3 engine locked in. They're already starting to work on XE4. So whatever that future looks like, they're doing the work for it. So it seems like they are in it for the long run, and that's something that a lot of people worried about with Alchemist. Is this just going to be a one and done generation? And hey, you know what? At least we have another generation in the books, so that is good.
This time, at least, they're aware that it takes a few years to spin this up. It's not just you roll out the first part and it's gonna go. The support they showed to Alchemist is great, but it is, depending on how you count it, the third or fourth time they've had a standalone graphics part. Some of them didn't ever see the light of day, but
Sure.
Yeah.
Well, but once again, I also do think all the work they're doing on the mobile side, which is very healthy, most of the world, relies on laptops. That's somewhere that they really care about, and us as desktop gamers are just getting, some of the benefits of the fruits of that labor.
And I think that's the thing that separates this time, right?
Mm-hmm.
Like, I think that's the differentiator, and that's why we're seeing the success we're seeing. It's why we're seeing the adoption we're seeing from developers. Because if you think about it, having XeSS2 on a Lunar Lake laptop gives, as a game developer, gives me a good way to demo my game when I'm at GDC or at E3 or whatever. I guess E3 doesn't exist anymore, but it's good to support these laptops, because with the upscaling and with the frame generation, all the stuff that you can do with these new parts, suddenly the little tiny GPU inside my Lunar Lake laptop looks a lot more capable.
Yeah. So speaking of capable,
Yeah.
I think it is a capable part. Still more to come in terms of testing. We have some ideas for further testing, but if you have something specific you want to see tested, definitely leave that down in the comments below. Thank you for getting through this whole video. A lot of numbers to run through. And be sure to subscribe here on PCWorld for more PC hardware and software goodness. Thanks, Will. Thanks, everybody. We'll catch you in the next video.